In this demonstration, we will show how SETL's LedgerSwarm framework integrates with the DREX platform to provide privacy, scalability, and programmability. We will demonstrate a CDB smart contract, which will allow the issuer to issue a certificate of deposit, transfer that certificate between owners, pay a coupon, and redeem a certificate of deposit. All these operations are demonstrated across multiple private DREX ledgers, settling each transaction in an atomic wrapper. First, let's look at the architecture of LedgerSwarm. LedgerSwarm has three primary layers. The ledger layer is where balances are recorded and updated. Ledgers are a property of a legal entity, such as a bank, so LedgerSwarm allows each participant to maintain a private and separate ledger. LedgerSwarm can connect to existing core banking platforms and to DLT ledgers. In this demonstration, each participant is running its own BSU blockchain ledger on which it has deployed tokenizado contracts to represent each asset, cash or securities. We have deployed three participants, DREX Bank 1, DREX Bank 2, and DREX Central. The orchestration layer is where transactions, which span multiple ledgers, are managed. This layer synchronizes between those ledgers. LedgerSwarm allows for multiple orchestrators or settlement domains, which can be connected in a decentralized network. The orchestration layer is where settlement finality is declared. The business layer is where participants can interact in complex ways. LedgerSwarm offers a cross-ledger smart contract framework. It is this layer where we have implemented the CDB functionality in the CDB Registrar smart contract. First, let's look at the demo environment. We have three participants, DREX Bank 1, DREX Bank 2, and DREX Central. Each of these participants is running a segregated blockchain environment with their own smart contracts deployed to maintain their own token balances. You can see that DREX Bank 1 and DREX Bank 2 both have accounts at DREX Central for Brazilian Real. The balances shown on the screen are a direct reflection of the balances held in the corresponding tokenizado contracts on each BSU blockchain. Let's look at Alice's balance here. And on the DREX BSU blockchain, let's do a transfer from Alice at DREX Bank 1 to Bob at DREX Bank 2 to show you how that works. Every transaction on LedgerSwarm starts as a proposal. You will notice that the proposal contains only the originating and destination accounts. An account is identified by a domain, a participant, and an account identifier. When this proposal is put to LedgerSwarm, it will query the sending and receiving banks to discover where each of them settles the instrument being transacted. It does this recursively until it finds a common settlement destination. In this case, the settlement destination is DREX Central. Having discovered the settlement route, LedgerSwarm sends the proposal to each participant and awaits assigned authority to proceed. This is when each bank will do their fraud and sanctions checking. Only when all participants have agreed is the transaction finalized and committed to all the ledgers. To speed things up for the demo, all three banks will automatically approve transactions. Now, when we submit the transaction, you can see the proposed postings for each ledger. DREX Bank 1 will debit Alice and credit its Nostro account with DREX Central. DREX Central will debit DREX Bank 1 and credit DREX Bank 2, and finally DREX Bank 2 will credit Bob and debit its Nostro with DREX Central. All of this is done as a single atomic transaction across the three ledgers. Now let's look at a certificate of deposit issued by DREX Bank 1. Here we can see that DREX Bank 1 has an inventory of 100,000 of a CDB, which expires on 2nd October 2026 and has a coupon of 13.25%. This balance is recorded on a tokenizado contract. From this balance, we are going to issue 1,000 to Alice, who will pay face value for that certificate. Alice will then sell 400 of her CDB holding to Bob at DREX Bank 2 and 100 to Charlie at DREX Bank 2. Each of these will be done as an atomic DVP transaction. We will then pay a coupon on the CDB and will observe how the payment to Alice, Bob, and Charlie are settled across the different ledgers. Finally, we will redeem the certificate of deposit and show how the redemption value is paid and all of the holdings are redeemed back to the treasury account at DREX Bank 1. To do this, we will set up a LedgerSwarm CDB registrar smart contract. This contract keeps track of where all the holdings are, executes corporate events, orchestrates transfers between holders, and manages the redemption of the certificate of deposit. To launch the contract, we give it some basic information about the certificate of deposit and point it at the tokenizado contract at DREX Bank 1. We also assign a party to be the registrar. In this case, we choose DREX Bank 1, but it could equally be a third party acting as the registrar. With all these details, we create a new instance of the registrar contract. Each CDB would be represented by its own registrar contract with functionality and parameters, which is specific to that issue. Let's look at the contract we just created. You can see that it has several functions that can be called by the registrar. The first thing we need to do is to agree to this contract. We do this by calling the register function. Nothing will work on the contract until all parties have agreed to it. Now we are able to call our first function, issue certificate. We issue 1,000 to Alice at DREX Bank 1. Let's have a look at how that is reflected in the DREX Bank 1 ledgers. You can see that Alice now holds 1,000 certificates and has paid 1,000 Brazilian real to Treasury for those certificates. The smart contract has orchestrated these two movements as an atomic transaction. Our next operation is to sell 400 to Bob at DREX Bank 2. We do that using the transfer certificate function. It takes a from and to account and a price at which the certificate is sold to the new owner. Let's look at how the ledgers reflect this transaction. You can see that certificates are transferred through a DREX Bank 2 account that is maintained at DREX Bank 1. Then at DREX Bank 2, they are allocated to Bob's account. You can also see that Bob's payment is routed through DREX Central, following the settlement path that we previously examined. We will do one more transfer, this time to Charlie at DREX Bank 2. Looking again at the ledgers, you can see that DREX Bank 1 records the total amount held by DREX Bank 2, and DREX Bank 2 records the beneficial ownership split between Bob and Charlie. Now let's pay a coupon. Because the registrar contract is keeping track of the holders and which ledgers they are on, it can create the right set of payments from the issuer to the holders. LedgerSwarm will take care of the settlement of those payments, no matter how complex. So let's make a payment of 13.25% by calling the pay coupon function. Again, looking at the ledgers, we can see that payment to Alice is within the DREX Bank 1 ledger, but payment to Bob and Charlie is across DREX Central. Each payment is in proportion to the amount held by Alice, Bob, and Charlie. Finally, let's look at redemption. For this, we will call the redeem certificate function of the smart contract. And again, let's look at the ledger. We can see that the certificate face value is sent to each holder in accordance with their holding, and each holding is transferred back to the Treasury account at DREX Bank 1. That completes the life cycle of the certificate of deposit, and the smart contract is complete. To summarize, we have set up 3 participants, each with their own ledger. Those ledgers record balances using the DREX tokenizado contract. Movements between those ledgers is orchestrated by LedgerSwarm, which works out the settlement route between the sender and receiver. Transactions on LedgerSwarm are in an atomic wrapper so that all ledgers remain in sync. We deployed a CDB registrar smart contract to manage the life cycle of a certificate of deposit, including issuance, transfer, coupons, and redemptions. Please let us know if you have any questions.